Assalamualaikum warahmatullahi wabarakatuh. My name is Berlian and I will explain the book of Professor Doctor of Engineering Bambang Triatmojo, and the title is Hydraulica 1 from chapter 1 until chapter 3. Hydraulics comes from the word hydro in Greek, which means water. Thus, hydraulics can be defined as a branch of engineering that studies the behavior of water both in a stationary and in motion. Hydraulics can be divided into two fields, namely hydrostatics, which studies liquids and stationary states, and hydrodynamics, which studies moving liquids. The science of hydraulics has an important meaning considering that water is one type of fluid that is very important for human life. Fluid is a liquid that can flow, which has particles that are easy to move, and it changes shape without shifting mass. The fluid reservoir against change in the shape is very small, so the fluid can easily follow the shape of the room or place that limits it. Fluid can be divided into two types, namely liquid and gas. Hydrostatics is a branch of hydraulics that studies liquids at rest. In a stationary liquid, there is no shear stress between the liquid's particles. An object that is in a stationary liquid will experience the force caused by the pressure of the liquid. The pressure works perpendicular to the surface of the object. Moreover, the pressure acting on a point is the same in all directions.
Hi, my name is Ammar and I will explain the book by Professor Doctor of Engineer Bambang Triatmojo entitled Hydraulica 1 from chapter 4 to chapter 6. Chapter 4 with the title Balance of Floating Object. In the previous chapter, it was studied that objects immersed in liquid experience pressure on their surface. The horizontal component of the pressure force acting on the object are the same, but in opposite direction, so that they cancel each other out. The downward vertical force component caused by the liquid acts on the top surface of the object, while the upward component acts on the lower surface of the object. Because of pressure per unit area increases with depth, the upward component is greater than the downward component. This upward force is called the buoyancy force. Floating objects such as ship, life vest, and others use the principle of floating object. Chapter 5 with the title Liquid in Relative Balance. The liquid in the tank, which moves at the constant speed, does not experience shear stress, because there is no relative motion between the liquid particles or between the liquid particles and the boundary plane. The liquid in this state is said to be in relative equilibrium. If the liquid is accelerating, there will be a force caused by the acceleration which adds to the hydrostatic force. Chapter 6 with the title Liquid Kinematics. Flow kinematics studies the motion of liquid particles without considering the force that caused the motion. In this case, the velocity is studied at each point in the flow field at any time. In the flow of liquid, the particle motion is difficult to follow. Therefore, the velocity at a point is usually determined as a function of time. After the velocity is obtained, can be obtained the pressure distribution and then the force acting on the liquid.
Assalamualaikum warahmatullahi wabarakatuh. My name is Tiara Amalia Suksesi. In this moment, I will present my summary. on the book of Babang Triatmojo. The title is Hidrolika 1, and I will present it 3 chapters. The first chapter is about dynamic of motion of liquid due to the influence of force that work. In this chapter, we will study about the Bernoulli's equation. Derivation of the Bernoulli equation for flow along a current line is based on Newton's true law of motion. Bernoulli's equation for real liquids. Derivation of the Bernoulli equation is done by assuming that the liquid is ideal or inviscid, so that there is no good friction between the liquid particles and the boundary walls. This chapter will explain the momentum equation, some of its application. The momentum equation of a particle or object is defined as the product of mass and velocity. According to the Newton's true law, the change in momentum can cause a dynamic force and additional force on the hydrostatic pressure force. And then force is generated by the change in velocity. Next, the stagnation pressure. The stagnation pressure shows that an object that is in liquid flows and its direction will change except for the middle current line, which cut the problem at a point. And then dial speed. To determine the velocity of liquid flow in the pipe using a pitot tube, it is necessary to obtain a different measurement between the heights of the stagnation pressure and the height of static pressure. And then dial discharge. The flow rate through the pipe can be measured using a venturi member. This tool is installed on the pipe to be measured the flow rate. This increase in speed will result in a decrease in pressure. And next, liquid jet. The path is a flow line. Since the pressure in the beam is the atmosphere, the height of the pressure at any point in the path is there with the velocity height plus the elevation. And next, the last chapter is about spillway. In the large hole, if the upper side of the hole is above the water level in the tank, then the hole is known as a spillway. In this chapter, a hydraulic overview of holes and spillway will be described. Firstly, flow coefficient. The contraction coefficient depends on the energy, height, shapes, and size of the hole. Its average value is Cc. The ratio between the real velocity of the flow in the contractile vein, or Vc, and the velocity coefficient value depends on the shapes and the hole size and the energy height. The mean value of the speed efficiency is Cv. The next is flow through the hole. In the flow through the vein or spillway, the energy level is usually constant and or change due to the outflow. If the height energy is constant, then the flow is steady. Whereas if the height energy changes, then the flow is unsteady. In the flow of the hole, there are several analyses of the state of the hole, which can affect the flow. Small holes, submerged hole, and a large hole. Yes. And the last is spillway. Spillway is similar to the large hole where the level of the liquid surface upstream is lower than the upper side of the hole. Spillway is usually used the measure of flow rate. The discharge calculation will be different if the type of spillway is also different. I think enough for my presentation today. If there are many mistakes, I'm sorry, and for the attention, I say thank you very much and wassalamualaikum warahmatullahi wabarakatuh.